Hi everyone, this video here I'm doing a test with my magnet rotor in there, which is presently turning with the coil position with the magnets hitting the coil on the side of the coil. And all the magnets have been arranged in a monopole order. That is, all the magnets are in the north direction across that side of the coil. And there's a total of 8 magnets there, and it is turning at this time. And I've had it running for a little while now so that the heat can establish or stabilize. And it is turning at 3,540 RPM and pretty stable at that point right there. And let's have a look here at the voltage here. So there is a little bit of fluctuation in the voltage coming out of the variac, and in general I'm around 67 volts, and I would say plus or minus 0.5 volts from what I can tell there. So I'll keep the video on it for a bit here, and below, so right here, this is the voltage coming out of the variac to the unit there, and maybe it could be as high as 0.6 volts variances. So there's a little bit of variances. Oh, there we go, we're 66.5, and probably all the way to about 67. So maybe up to a 1 volt variance. No, it's dropping there again. So that could be the fact that there are some heaters, electric heaters on this home, and they're engaging and disengaging, so I am getting some variations in the voltage there. And there is the current draw coming from this meter here. So as the motor warms up, we're probably going to stabilize somewhere around 550 milliamps of consumption at approximately 67 volts. So right now we're at 66 volts, and again now it just shot up. I believe as well the oven or stove is being used at this time for cooking, so that's also electric. So all these consumptions on the home could be varying the voltage at this time. Now let's have a look here of the setup that I have on this coil right now. Here are the 2 leads coming from the coil. I have a diode that is positioned right there. And let's see here, let's have a look. There's the diode. So the positive spikes here would be going through the diode, and I have a 1 ohm resistor across the 2 leads. My 2 grounds to my probes are right there, and there's the other side of the coil. And I attached as well a 30,000 microfarad capacitor there to keep the DC nice and flat, and so that I can actually get a real reading on the voltage meter on the DC scale. And we have 0.124 or 0.123 volts, sorry, across that 1 ohm resistor. And one of the probes here, so the green probe here, is pre the diode, so basically across what's coming out of the coil, and the next probe here is on the other side of the diode, so it would be what's across here on the resistor. And this is the scope shot, so I tried to get it as stable as I can. So basically these spikes here are the magnet hitting the rotor, so the magnet arriving and the magnet passing. And basically these other spikes right here are when the diode engages and then again disengages. So again, here in green is the coil activity, and here in yellow is what is happening on the 1 ohm resistor. So that's giving you an idea there. So the idea here is actually to collect the when the coil, when the magnet has passed and the coil collapses. So we're only collecting the collapsing side, not the entry side of the magnet, and seeing what the effect would be of doing that. And there is the data there on the scope. Don't mind this here RMS reading, because now we have actually a capacitor. If I take the capacitor off, it'll shoot up to about 0.123 volts as well. So there's the frequency it believes it is at. So I don't know how useful that is. I guess it's basically just looking at the waveform here that's a little more important. And here, if I disconnect the one of the leads here to the 1 ohm resistor, so going through the diode there, let's have a look here and get a reading. So right now we are connected, so we're at 0.5, nearly 6, and now it's disconnected. So I could hardly get any kind of differences in that. So once again, connected now. Disconnected. Connected. Disconnected. Connected. Disconnected. Connected. Disconnected. And as well, the RPM is 3540, so very, very stable. And now I'll connect it, and we're at 3540. So I can't really tell any differences connecting the that load on the coil, but only on the flyback, more or less, or the collapsing side of the coil on the load. So I can't really pick up any differences as far as current or RPM, or an RPM drop, or a current rising with it connected or not. So that's what this test was about here, and we'll do other tests as well. I think though the fact that we have only 0.123 volts across our 1 ohm load, I think it's very minimal for seeing an RPM drop on the motor or a current increase. I guess that's about all I can do with this test, and let others post what they think of this. Thanks for watching. Bye.